So we will explain something on the case studies on the concrete recycling, what we did in the HISER project. My name is Roekel. I work for Structon, a large infrastructure company in the Netherlands, and this is Francesco Maio from the TU Delft. And together we worked on the technical solutions, which Francesco will explain a bit more about it. And then I will show via a video what we did on the case studies. You can experience a little bit what we did, and I will also explain a little bit more what are the next steps we already did within the HISER project, but also within the Netherlands. So I give first to Francesco to tell something about the technical solutions.
Can I give you the floor to you? Good afternoon, everybody. Yes, I'm Francesco Di Maio from TU Delft. And today, actually, the title was quite a long title, but basically what we want to do is to make concrete circular, because in the next year, especially in Netherlands, the Dutch government has set the target that by 2050, everything should be circular. Not only the wheel, but everything should be circular. Maybe even us should be circular, and I think that I'm quite linear now. I think I have to increase my input food. Maybe you are a little bit more circular than me. But this means that we really need for us, the circular means that we have to go from the waste concrete and make new concrete. This is what we want to do. And in order to do this, we need to make the value of the materials, which is in concrete, the same value as the virgin materials. Otherwise, it is not going to be circular. By definition, it's impossible, because even if we use the concrete from waste concrete to make a road, it is a good application, definitely. When there is a road to be made, it is a very good application, but it is not circular. We do 100% recycling in that way, but not circular. So then, concerning technology, to make circular concrete, we need technology, definitely, and this is what we have been busy with within HISER as a Technical University Delft. But we need also something else, and this is what Eric and the Structon has been busy with, to make really all the other components which are as important as the technology to make the concrete circular. For the technology, this graph shows the working principle of an advanced dry recovery, which is the technology developed in Delft, which makes separate the crushed concrete into a fraction which is 1 millimeter fraction. This is a 16 millimeter fraction, and this is a 0.01 millimeter fraction. And in HISER, we have been focusing on this, on the coarse fraction, and by using this technology, we have produced concrete having higher mechanical properties than concrete made using virgin aggregate. Then we solve this problem, at least from the technical point of view, it is technically feasible. And we did this not only, this is a picture which shows how the materials looks like. You can see it is very clean. There is nothing different than a virgin aggregate. This is the fine fraction, which is a little bit polluted, but we solved also this problem within another European project, but we are not going to discuss this now. Maybe Eric will say something about this. We developed this technology. As I said, the mechanical properties are higher. Here you see the compressive strength of the concrete using 100% of recycled aggregate, which has higher mechanical properties than the concrete made using virgin aggregate. And we did this in several experiments. It is consistent. It works. The recipe for making concrete is not the one used in the normal ready-mixed concrete, but it is not written in the Bible that recipe must be used. You can also adapt it. And we did, when we are talking that we made the technology at industrial scale, not at lab scale, but at industrial scale. This machine works at 70, 80 tons per hour. And it works, we also developed a mobile version of this machine, which can be brought to the demolition site. And this, of course, increases much the business case, which later on Eric is going to show to you. And then we also, another important feature which we need, issue which we need to address is the quality. The quality has to be assessed. This doesn't mean that the quality of the materials has to be necessarily the top. But the issue is that the quality has to be assessed. Otherwise, when there is no way to assess quality, that materials has no market value. We need to know what is there. It's bad or less or good or less good, but the point is must be assessed. And by laser-induced breakdown spectroscopy, we managed to make this quality assessment equipment. This is the way it looks like in the labs. And this is when we tested in the Horn recycling site where of a GBN of a Structon in Horn. And this is the pilot plant made at the Technical University Delft. You see there is concrete going on a conveyor belt and a laser which scan the materials and give you information about the quality. And this is another picture of this the same machine. And these are some details about the libs we have developed. Because we have to check what are the main pollutant, and we have to quantify those pollutants. This can be done, and then the information can be used to assess the quality of the materials. And we are also working to make this in a more automatic way. And this is also we used the aggregate from the IDR to make concrete, but using the standard technology, the standard ready-mix concrete recipe. And we have got also very good results. And also durability. Here you see these are IDR 0412 millimeter, and we use two different cement. And here you can see that the quality, the compressive strength reach the target and outperform it. And also other durability parameters are also fulfilled. Then this means that even using normal ready-mix plant, it is possible to use recycled aggregate to make high-quality concrete when using IDR C2CA technology. Then later Eric will provide you more details. These are also some durability tests we have carried out. You see that this is the water penetration profile, and then there is the chloride penetration profile also here. They are completely in line with the tests done using virgin aggregate. So this means that these are just a summary of the results. In few words, this means that the recycled aggregate produced by C2CA technology is absolutely suitable to make new concrete with high mechanical and durability performances. Okay, I mean, these are just the details of this test. I guess you will get the presentation. I mean, I don't need to go into the number. I want just to put it just to show that they are there. We have made extensive tests. It works. And then now this is already your part or my part? I think it's start your part now.
You may tell something, but maybe it's easier if I do.
Okay.
I am more circular. This is the part about the case studies. So the objective of the case studies was demolish a non-residential building and closing the complete loop of concrete recycling. We did that in Almere. This is the old building, and actually on the same site they built an upcycle center, which means people from the area of Almere bring their waste there for upcycling. So that was a very nice project to do together with the government of Almere. Can you play this video, please?
Here in the heart of Almere lies Project Steiger 13. This is a former printing store and warehouse which is currently being demolished. But nothing gets thrown away. Together with Maio Group, demolition company Maton de Roy and the municipality of Almere, the GBN managed to give 85% of all the demolished building materials a new life.
Well, normally there are about 10 different material flows on each project we search further. Ultimately, we made up a list with 78 different material flows. For each material, we search for a second life in the region. The Kringloopwinkel Almere takes 45 different materials. These are materials like doors and light switches. The roofing material goes to roof, and 3 material flows will be directly reused in the newly constructed building on this location. This creates a circular demolition in which raw materials are reused and as little as possible is extracted from nature.
But what do you do with all the concrete and debris? Together with the University of Delft and 12 international partners, including GBN, they started a European finance program to be able to recycle concrete debris in an environment-friendly way.
We are in Horen at the concrete recycling site. At this site we can recycle end-of-life concrete in a way that can be used in new concrete. Once the end-of-life concrete arrives in Horen, it will be separated in end-of-life concrete and mixed rubble. Mixed rubble will be crushed into road-based aggregate, and the road-based aggregate will be used to make a new road. The end-of-life concrete will be crushed and sieved into a 0 to 12 mm fraction and a 12 to 22 mm fraction. The 0 to 12 mm fraction will be transported with an input hopper and a conveyor belt directly into the ADR. The ADR stands for Advanced Dry Recovery. It's a new innovative technology that will separate the fine fraction from the aggregates, and the production of the ADR is 60 tons per hour. Comparing with traditional technologies, the advantage is that you don't need a lot of water or have to completely dry the aggregate before sieving, and it also will remove the contaminants out of the 4 to 12 mm fraction. The ADR separates the concrete aggregates into fractions of 0 to 1, 1 to 4 and 4 to 12 mm. The 4 to 12, the 12 to 22 mm goes to the concrete plant of the Maio next door. Here it is processed into a high quality replacement of natural aggregates. For the 0 to 1, 1 to 4 mm fraction, we are developing a new technology to make it suitable for the production in new concrete.
The concrete recycling project is bundled in a European research and innovation project called HISER.
The project HISER received funding from the European Union under the Horizon 2020 Research and Innovation Programme. There are 9 different countries actively involved in HISER. The main objective of HISER is to develop and demonstrate innovative and cost-effective solutions to increase the recovery rates of materials from the construction and demolition waste. These solutions will be demonstrated in demolition projects and 5 case studies across Europe.
So with the advanced dry recovery, we are ready for a new environment-friendly method of concrete recycling.
So here we saw the video of the complete case study. What we did for the demolition project, also together with the University of Leiden, looked at the business as usual model and also a best practice model. Well, we compared it together, and we see that the best practice model was better. We saved a lot of money. We saved a lot of CO2. A big part of it is from the metal beams we could replace on site. But what we've seen is that you put some effort in it, you have some time up front and look good at the object. There are many possibilities to reuse materials in other buildings. Is it easy? No, it's not easy. Is it widely accepted already? No, it is not. But so you have to start somewhere when you want to change something. Dus we see that, for example, in the Netherlands, we have we looked at with the BIM smart demolition tool. We talked with the Madaster, who is registering all the new materials from today, and also a BIM tool based on new products. Maybe we can combine it with the BIM smart demolition tool. We see that you need open networks, that if people have small ideas together, you open up the project, and a lot of reused options will be available, but you have to organize it. So our opinion is that we are in a transition model looking at circular economy around demolition projects. But we see there, especially for the Netherlands, where there's also a high demand from the government to be circular, and with ambitions in 2030, 2050, that they really ask this in tenders. What can you do with the demolition of the building? How can you make it circular? So we see there a new market. Looking at the concrete product, we used the concrete from the project. We made new concrete in the project Almere. We made new concrete with Maio, a part of Heidelberg, who's next to us in Horen, where we can recycle the materials on the same site. But we have continued, because within the HISER project we started with, you see it here, it is on containers, it is big, it's easy to move, but it will take you a couple of days and costing you a lot of money. And in October 4th we launched our new developed technology, and here you see the same machine, but now it is on wheels, so we can go to the project within a day and use the technology. We also set up a company for this called C2C Technology. It was also mentioned in the HISER project that if there is something we can do with the technology, we should commercialize it to bring it further. So we set up a new company called C2C Technology together with TU Delft and Structon, where we develop new recycling technologies for complex building materials such as construction and demolition waste, and in this case it is specialized on concrete. And here on the right you also see the new machine who can handle the 0 to 4 fraction in separating it into a 0 to 200 micron active fraction, a sand fraction, and what it also does, because you see the insulation, so it has to do something with heat. It will clean the material from all contaminations like wood and plastics. So looking at closing the loop, we see the old way, where we have the concrete from the building to road construction, and as Francesco said, we do it every day because we build roads. We use a lot for road construction, and when you do it on the same site and you make an LCA, it is one of the best solutions. But towards future, we think that if you can use ADR and also another new technology, you can completely close the loop. Where our colleague from the aggregate industry said we can replace about 10%. We agree actually. In the Netherlands we think it's about 15 to 25%, more or less. But we say we should reuse 100% of the concrete, what is coming from demolition projects, into new concrete. And if we replace 5%, 10% or sometimes 50%, it doesn't matter. It should be in the right product, and we should work on for example, the lips is very important on the quality, that when you make concrete, like Leo from Maben or Lafarge, you make concrete, you make it for large projects. You have to give a guarantee, not for 1 year or 2 years, it's 50 years. You cannot update like software. In the weekend, you say it's offline for 1 hour, the bridge is offline, and on Monday you can drive over the bridge again. So you have to be sure of when you use new materials, that you have the guarantee that they are good. If we replace a part of the cement, it's not a problem, but we have to know that the product we replace it with, we have to know what it is. So we have to identify it. So we have to invest more and more in that research. Here we launched technology. We saw in the Netherlands there was a very high interest for the new technology. And what is very interested in the Netherlands is that we have signed a concrete agreement. And we worked on that also actually during the HISER project, and a lot of things from the HISER project could help also the concrete agreement. Because we started with the Green Deal, where the government says, okay, we as a government and you as the market, we should work together, not by law and legislation, but just as people working together towards a combined ambition towards the future. We signed this agreement, and in this agreement, there's a lot of things in this agreement, but one of them is a CO2 reduction ambition. One of them is the 100% circular concrete, meaning that all the concrete waste should go into new concrete products, not that all the concrete should be 100% circular, because it's just not possible. But what for us is very, very, very important is this one. It says that in each new cubic meter of concrete, there is at least 5% of secondary materials in it, and it can be sand, it can be cement, it can be the aggregates. And with this discussion, it helps us, because now it's not the discussion we have with 0% or 20. It is 5 or more, depending on what are we building, what is the availability in the area, because sometimes there's a lot of material available, sometimes not. And if it's not available, it's not a problem. You don't have to drive it from Den Helder to the other part of the Netherlands, because we have also a balance. That we say we should not do stupid things to reach the minimum of 5%. It should be an average going up based on new technology, and it should improve everything. We signed the first concrete agreement beginning of, or actually in October last year, I think it was. And actually yesterday, on the concrete day, we call it in the Netherlands, there was the final part. Because one thing was very important, also the European Commission or Europe has to say something about this agreement, because also governments sign it. So it was clear that it was okay that the Dutch government can execute also this agreement. But what was also important for us is that two companies within the Heidelberg Group called Maio and NC had to sign the agreement, and that was a bit more difficult because Heidelberg is a big company and the Netherlands is a very small part of their business. So they had to do, well, they have a lot of departments, I guess, who have to check that contract, but they signed it, and that is very important for the market, that from the cement production to the recycling company to the demolition company is part of that agreement. And actually here, this is the stand of on the exhibition. It says sustainable concrete from Rijkswaterstaat, ProRail and the Dutch Building Agency, using our HISER ADR fraction. So we see that it is really moving ahead now in the Netherlands. And we also have projects for the next years together with the government and the industry to demonstrate, to upscale. We have the mobile ADR, we have to upscale the fine fraction technology, the HAS, and we do that together with the market, together with the government, together with the concrete industry, but also with the construction companies. So we believe that we are really moving ahead now, especially with the concrete recycling. Questions for me or Francesco?
People believe that it would be, I believe that it would be when it is now going to be, this cement is removed from the surface of the aggregate, the interfacial transition zone has different characteristics than the one of the virgin aggregate. And another reason, both chemical, physically, but then also because of the roughness of the materials is not smooth from like stone from the river, but it is more rough. Then the surface area is higher. Then this would be an explanation, but we don't have a scientific explanation.
Okay, thank you. It's hard for me to imagine that a physical process like ADR would change something compared to a normal crushing process. So maybe two suggestions is there are less fines in your 4 to 12, which can have an influence.
But the reference is with the virgin aggregate. The virgin aggregate has defined.
No, my point is that sorting and taking out your fractions 1 to 0 and 1 to 4 in the process you've shown doesn't seem to affect the surface of the 4 to 12. Or maybe I'm wrong, I don't know the process, of course.
Okay, maybe I explain a little bit what... okay, then we have to go back to the first slide. But what you see, what the ADR is doing, it acts like a separation.
It's an impact
sheet,
crusher or something.
but also something happens because the stones go in with a very high speed, getting into contact with the iron body of the ADR, actually liberating the sand, the cement, and the aggregate without crushing the sand again. So it comes into the other fraction. And we think that having a liberated aggregate by ADR processing with a rough outside might influence the early strength development. It's just we've shown it, but that's how it works.
Yeah, it's more or less a second impact crushing you're doing and separation step.
It's separation with also some action on the material.
There is also chemistry involved for many people.
Okay. Or your reference concrete is not that good. That's another explanation, of course. Well, it depends if you're improving. You can improve your concrete by using another particle size distribution, using your recycled material. Okay. Of course. And then the second question is for you, Mr. Roekel, is on the business case. Because crushing things once and using them, it's a quite straightforward process and quite cheap. And certainly if you succeed in having, let's say, 4 to 16, which you can use in concrete almost directly, especially with selective demolition. So is the benefit or the profit in the 4 to 12, or is it in the solution for the 0.1 and the 1 to 4 millimeter?
We look at it as a total process because we only treat material the way it should be treated. For example, what we've been doing in Horen is creating a we crush a 0 to 22 millimeters. We separate it at 12, and then one stream is treated by ADR. It's a smaller fraction, cleaning the 0 to 12, but also separating the contaminations in the 0 to 4 fraction. And that from ADR we have a 4 to 12 clean output. When we have the 12 to 22, we use a wind shifter on it, and we can really clean it because then we don't have the smaller fraction, so we can put it on a higher speed. We combine those two together, and we have a very clean 4 to 22. Then we have the 0 to 1, 1 to 4 millimeter fraction, and that is the fraction we are treating now with HISER, the heated air separator, and that will become a filler cement fraction, old cement fraction, and a sand. If you look at the business case, we think that if you get a higher amount, because if you only look at the crushed sand, for example, and we use it in road constructions, it is okay. But we see that there are many other materials especially from the recycling market, competing with road construction replacement materials. And in the Netherlands, we see a balance. We made already a lot of highways. That it would be interesting to upscale it a little bit and get more money for the finer particles. And having that extra money for the finer particles makes it a better business case. But again, crush it, put it on the road at the same site without thinking is the best business case still today.
Okay, thank you.
CO2 balance you announced on your field case, and especially I think you said that you are using locally the steel. How can you manage?
Yeah, that was from the building. That was the steel construction from the building. We reused in the new building.
It's not the steel from the concrete.
Steel from the concrete. No,
okay,
no, no.
okay.
No, we are not able to reuse that on site.
Well, I'd be interested.
Steel fibers, I guess. Yes. That was possible. Yeah. No, it was the steel beams of the building.
And how can you manage to have a lower CO2 imprint by this process? Because you spend some energy and at the end you put as much cement, so I don't see where you can really...
Transportation, if I remember correctly from the Leiden study, it was from the transportation. There was a saving in transportation.
Okay, but normally the weight of transportation is not so high, as compared.
Depending where you are transporting.
So the 42% or something like that was...
We have the reports from Leiden University. They made all the calculations on all the materials.
Okay.
I'm very pleased you had some areas of agreement with what I was saying earlier. So that's very comforting to know that we get to the same conclusion from our different directions. But a simple question. This is dry recovery. What happens when it's raining? Do you lose all your production?
No. The good thing of the advanced dry recovery, because that is why we are so enthusiastic about using it instead of a natural sieve. Because if you just crush it, sieve it, we live in the Netherlands and we have sometimes we have rain, actually most of the year. And what we see when you have high production and you want to sieve your materials on smaller fractions like 0 to 1, 0 to 1 to 4. And when it's raining, it's a real problem with your sieve, with your decks. You have to clean it all the time. What the advanced dry recovery is doing, because that is the nice thing about it, you can even put in wet material and you get exactly the same output. So even when it's dry, you can put in with, actually when it's raining, it's exactly the same.